Hi, today we are going to start our chapter on factoring. And the first thing that we have to learn is what a factor is. A factor is a number that another number is divisible by. So back in first semester, we did some prime factorization where we broke a number down by dividing it to get down to the prime numbers that we could multiply together to end up with that number. We do not have to have prime numbers in our factorization this time. We are looking for all of the factors, all of the numbers that we can divide a certain number by. So the first one that we're going to look at is 8. So if I take 8 and I think about what numbers can I divide 8 by? Well, I can always divide 8 or any number by 1. 8 is even, so it's divisible by 2. And it's 2 times 4, so I could divide 8 by 4. And if I divided 8 by 1, I would get 8. So any number is always divisible by 1 and itself. And then you also have to look for any other factors that it could have. All right, I also want to look at 20. So you can think about what factors or what numbers divide 20. And I can divide 20 by 1, 2, 4, 5, 10, and 20. So these are all the factors of 8. These are all the factors of 20. What we're going to be looking at in this chapter on factoring is what is my greatest common factor. So what is the largest number that both 8 and 20 have as a factor? And looking at the list, the largest number that they have in common is this 4. So we're going to be talking about greatest common factor, or GCF. And we're going to be talking about pulling out or factoring out the greatest common factor. So in this example, I'm going to show you how to find the greatest common factor of 3 separate monomials. Now they're called monomials because it's a single term. It can have numbers, it can have variables, and it can have positive exponents on those. So the first thing that we need to do is look at the numbers, and we're going to find the greatest common factor between 9, 6, and 15. And some of you may be able to look at this right away and figure out what the greatest common factor is. But sometimes the numbers are going to get a bit bigger, and so I want to give you a method to find that greatest common factor. What I do is I always start with the smallest number, because hopefully it would have the smallest number of factors. So my factors of 6 are 1, 2, 3, and 6. And then what I'm going to do is I'm going to work my way down the list from greatest to smallest to see if the other numbers are divisible by that number. Well, I know 15 is not divisible by 6. So if it doesn't work for all of them, it doesn't work at all. 3, I can divide 15 by 3 and get 5. I can also divide 9 by 3 to get 3. So my greatest common factor is 3. And then I have to look at the variables. So I need to see how many they all have in common. Well, this one has 2 x's, this one has 3 x's, and this one has 6 x's. So the amount that they all have in common is they all have at least 2 x's. So I'm going to make that x squared. And then I look at the y's separately. I have 5 y's, 3 y's, and 2 y's. So the smallest out of those exponents, the number that they would all at least have, is going to be y squared. So that's how we find the greatest common factor if our terms have variables. All right, now that you know what a greatest common factor is, we're going to factor out the greatest common factor from this binomial, and it's called a binomial because it has 2 terms. The 2 terms are either separated by a plus sign or a minus sign. In this case, it's minus. And we need to see what the greatest common factor between those two is. So again, I'm going to start out with my 4, which has factors of 1, 2, and 4. And I'm going to start at the highest number, and I know that 20 is divisible by 4. So my greatest common factor is 4. And then I have to look at the x's. This one has 6 x's, this one has 4 x's. So the most that they have in common is only 4, so it's going to be x to the 4th. Now, this question is going to ask me to factor it completely, not just find the greatest common factor. So I use this greatest common factor, and I'm going to put that out in front of the parentheses. This is similar to what we did in the last unit on completing the square. So we factor this out, but then all we have to do is see what's left over once I have taken out the 4x to the 4th. So I have 4x to the 6th. I've already factored out my 4. I've factored out 4 of these x's, which means I have x squared left over. And then this 20, it's still going to stay minus. 20 divided by 4 is 5, and x to the 4th, and I factored out all 4 of those x's, so this is going to be my answer. Now, we're not going to do it, but we've seen problems like this where we distributed, and this would be our answer. So factoring, it's called factoring, but I sometimes refer to it as undistributing because we are pulling that 4x to the 4th out of each of these terms and writing down what we would have left over. And this whole expression is what you're going to type into that box right there. Factoring out the greatest common factor is the same process if you have a trinomial. And again, this is called a trinomial because this time I have 3 terms. So I'm going to look at 18, 12, and 6. The smallest of those is 6. 6 has factors of 1, 2, 3, and 6. I'm going to start with my biggest number of 6. I know that 12 is divisible by 6 and 18 is divisible by 6. So all of these numbers have a factor of 6. So I'm going to put the 6 out in front, and then I'm going to look at the x's. This one has 3, this one has 2, this one only has 1. So the most that they all have would be 1. Put that out front, and then I'm going to go through and divide. So 18 divided by 6 is 3, and I have 3 x's, or x cubed. I already have 1 out here, so that means there's 2 left on the inside. I keep the sign the same. 12 divided by 6 is 2. X squared, I factored out 1x, so I have 1 left. And then I have a plus. And then 6 divided by 6 is 1. X divided by x, it's already on the outside, so I close my parentheses. One thing that I find that students make a mistake of quite frequently is when you factor out the entire term of the 6x, they will forget to put this 1. Now remember, if I turned around and distributed the 6x to each of these terms, I would need this 1 here to multiply the 6x by to get it back in my answer. But again, this entire expression gets entered in to that box. The final example that I want to look at is another binomial. I have the two numbers 23 and 81. Now I know that 23 is prime, so that means the only factors are 23 and 1. So I look at 81, and if I need to check on a calculator I can, but 81 does not divide evenly by 23. So the only common factor that they have is 1, and we're not going to factor out that 1. So over here we have this option of no common factor except for 1. And you may also see this as being prime. So if you see either of these choices where the only thing they have in common, they don't have any letters in common, that has W's, that does not. They don't have any numbers in common other than 1. You're looking for either the option that says no common factor except 1 or the term prime. So hopefully this helps. Feel free to revisit this at any point during the unit. And if you have any questions, ask me in class.